Hey guys, in this video we're going to cover C++. And what better way to start with C++ than to kind of see how it compares to the language that it came after, which is C. If you know C, then you probably know about 60% of the syntax used in C++. Variables are the same. We can declare integers, floats, doubles, and characters. For loops, while loops, do while loops, they are all the same, exactly the same syntax. If statements are the same. Creating functions are also exactly the same, as well as creating structures. So, if this is going to be the sequel to C, well, what's new? So instead of typing C as your file extension, typically if I wanted to write a program, it'd be as a .c file. But now instead of typing .c, we can type .cpp. And out in the wild, you could see other file extensions like .cc or a capital C. However, I'll be using .cpp. So why don't we start with Hello World. So the first major difference when it comes to C++ starts on the very first line. Instead of doing, we still do pout include, but instead of doing std.io, we're going to do iostream. However, the next few lines are going to be quite similar. And this, at its core, is the most basic C++ program that you can create. The only difference here is that instead of including std.io, we are including iostream. Now, one thing I want to highlight is that when you include iostream, you're also including std.io. So all the stuff that you're able to do using std.io, like using printf, scanf, functions like that, you can still use with iostream. However, C++ offers a different way of printing. And it is as so. So now instead of having our printing done as a function, we're doing something called opening an output stream. So here, it gets a little bit weird. So we're using 2 colons, and we're saying std : cout. Cout stands for character output, and when I type this, I begin an output stream. So when I begin an output stream, how do I add to the output stream? Well, I use this double angle bracket. This tells me that whatever's to the right is going to be added to the left, which is the output stream. So I add hello world to the output stream. So this gets added to std cout. Then I have another double angle bracket, and I have std endl. Endl meaning end line. So I create my output stream, I add a string to the output stream, and I add an end line. So what does end line do? End line adds a new line, as we would with \n, but it also does something else. It flushes out the output. With computers like this and more powerful ones like the ones on your laptop and desktop, it isn't really important to flush out the output stream. This is something that's more applied for microcontrollers and smaller hardware like that, just because they have so many different avenues of communications that are written to the same place, and it can get a little bit cumbersome, and sometimes you're left with junk there. Std endl flushes out all that junk as well as add a new line. And actually, this is not preferred when you're doing high-performance computing. You should stick with a new line if you're doing high-performance computing, because flushing out your output over and over and over again will slow your program down. When I personally write small programs, I usually use std endl, but now I'm trying to focus more on using endline. So what that means is that our printing statement would look like this. So instead of adding std endl to the output stream, I just end my hello world string with a new line. And this is how I go about creating a C++ program. Here's how I go about printing. I can use std endl to add a new line and flush the output stream, or I can just add a \n to add a new line. So how are we going to go about compiling now? Well, before we use GCC, and we would use something like hello.c. This sometimes may or may not work, and actually let's find out if it works. Oh, okay. It doesn't work. It won't work. So, we can't use GCC. Well, instead of using GCC, we're going to use G++. We're going to have hello.cpp. So G++ is a compiler for the C++ code. And like GCC, it'll actually produce an output file, a.out, just as GCC would. Right, so G++, just like GCC, will produce a.out. I can also use the same argument for renaming the executable, just like it is done with GCC. So if I run a.out, hello world, it looks almost exactly the same as C code. However, we are using C++, which adds a big difference. Std_cout is used to take over printf, but do we have a function to take over scanf? Yes we do. So here now I create 4 variables, a, b, c, and d. They are all integers, and that should not be cint, that should be cin. And what std_cin does is that, kind of like how std_cout creates an output stream, std_cin creates an input stream. So whatever we enter is going to go to the corresponding variables that we want the user to add inputs for. For this example, the first number that the user inputs is going to be D, the second number goes to B, the third number goes to A, and the fourth number goes to C. Notice how this is out of order from going in alphabetical order, and I wanted to highlight this to show you that you set up the input stream, and the order that you set up the input stream matters greatly. If I print the values, I'm going to see 3, 2, 4, 1. And actually, just to make things a little bit different, but what I'm trying to highlight is, again, you set up this input stream. I use the double angle brackets, however, in a different direction. So here I essentially do 2 less than symbols, and then here I do 2 greater than symbols. So here I add to the input stream. So D is added to the input stream, which means the first number that the user enters is going to be the value of D. And then I add A to the input stream, so that way the second number is going to be the value of A. I add B to the input stream, so that the third number is going to be the value of B. And then finally, C gets added to the input stream, so that way the fourth number becomes the value of C. And I just print them in order. So why don't we see the output of this result? And here we are. As you see that I entered these values, and because this is D, then A, then B, then C, when I print A, B, C, D, the numbers are correct because I'm printing the variables in that order, even though that the sequence of numbers that are printed here are not the same as here. And again, that's to highlight when you set up this input stream, the way that you set it up is very important because that's the way that data is going to be read. Lastly, what I'd like to cover is, what does this mean? What does std::: mean? Well, it means that cout, endl, and cin, they are part of something called a namespace. And what a namespace means is that it allows us to define special functions and normal functions that belong to a particular group. So these 3 functions belong to std. And this is nice because this allows me to define my own cout and my own cin and my own endl without having to worry about having name conflicts. There are many more data types and functions that are part of the std namespace that you may end up creating your own versions for. And it is quite important because your C++ compiler won't be able to tell the difference in saying that, hey, am I going to use a user-defined cout or am I going to use the standard library cout? And including this namespace destroys any ambiguity. You will see some programs that have something like this using namespace std but I personally avoid using it just because I go and I define my own data structures, and sometimes when I do define them, and I have done this before, even by accident, I've defined data structures that are actually part of the std namespace, and that can be dangerous because if there's ambiguity, well, if I create a data type called list, which is list is part of the std namespace, what is my G++ compiler going to do? What's my C++ compiler going to do? Is it going to use my list data type that I provided, or is it going to use the one that's part of the std namespace? Who knows? So this is why I like to add that. Also, other libraries put their variables and functions as part of their own namespace, and that's really nice because you know what pieces of code belong to which function and which library. So if you end up having to change libraries and you have something like using namespace, and let's say I'm using a library called metal, and now I have to take this line out and I have to go debug and run my code and see what data types, what functions, what other things are part of the metal namespace. And that can cause a big headache. So while you might see this using namespace line, I strongly would discourage you guys from using that. That wraps it up for this video. I'll see you in the next one.